Hi and welcome back to my channel. This week's problem is about finding the radius of this circle. Now, as you can see, we've got three chords that touch the circumference of the circle and touch each other at the points A, B and C, and we've got lengths of 9, 10 and 11, but those lengths could be arbitrary, so they really could be anything. We could change them to X, Y and Z. Can you find the radius of this circle? If you want to solve this problem yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing I would do with any circles related problem, as you know if you watch the channel, is to draw on any radii to key points. Now you could draw on all three here, but actually it's only two that you need to draw on, only two that are necessary. Now I'm going to use a circle theorem here. I'm going to call this angle between AB and AC theta, and then using the circle theorem that the angle at the centre is double the angle at the circumference, I know that this angle between B and the centre in C, the the obtuse angle, not the reflex one, the obtuse angle is 2 theta. Now from there I am going to use the cosine rule because I've got two triangles I can use now. I've got A, B and C I can use that with that angle of theta, and I've got BO for the origin, BOC. Okay, now first of all I'm going to use the triangle ABC, and I'm going to do 11 squared because that has to be opposite the angle. The A has to be opposite the angle for A. So 11 squared equals 9 squared plus 10 squared minus 2 times 9 times 10 cos theta. I'm going to simplify that, or calculate the squared values and the 2bc, and I get 121 equals 81 plus 100 minus 180 cos theta. Simplifying that a little bit more, 121 is equal to 181 minus 180 cos theta. Take away now the 181 from both sides and we get negative 60. Divide by negative 180 on both sides and we get 1/3 is equal to cos theta. Now I'm not going to calculate the value for cos theta, for theta straight away, because that will give me a decimal which I'll then have to round, but if I can use cos theta later on, that will give me an exact value. So we're going to leave it as cos theta. So let's put that over there. Now, I'm then going to use that triangle BOC that I mentioned earlier and do the same thing. So I'm going to say 11 squared is equal to r squared plus r squared minus 2 times r times cos 2 theta. Simplifying that, I get 121 is 2r squared minus 2r squared cos 2 theta. Now from here, I'm going to use the double angle formula for cos 2 theta and replace that with 2 cos squared theta minus 1. From there, I'm going to expand that bracket and get 2r squared minus 4r squared cos squared theta plus 2r squared is equal to 121. Gives me 4r squared minus 4r squared cos theta. Factorise the r squared out because remember we're solving for r, and we get r squared brackets 4 minus 4 cos squared theta. And then what I'm going to do is replace the cos theta now with a third, so we get r squared brackets 4 minus 4 of a third squared, which a third squared is 9, or a third squared is 1/9 times by 4. I was doing the 3 squared. A third squared is a 9th, times by 4 is 4/9. We end up with 4, take away 4/9 in the bracket, which will simplify to 32 over 9. We're then going to divide both sides of this equation by 32 over 9 and get 1089 over 32 equals r squared. We're going to square root then both sides to get the radius, which gives us an answer of 33 root 2 over 8 as the exact value for r. If you are able to get this yourself, very well done. If you've got a different solution, please put it down in the comments below. Now, I want to say thank you very much for watching, and if you have not already but you liked this video, please drop a like, and if you're not already, please consider subscribing to the channel. Now, there will be some other videos that you can watch just up here if you want to, so check those out. All that's left to say though is have a great week, and I will see you next Monday at 5 PM for another problem solving video. Until then, bye bye.